So let's start SCF and LCM now. I hope that part was clear to you, the divisibility part. Now let's quickly look into SCF and LCM part. Okay, what is LCM? Highest common factor. What is the meaning of highest common factor? Suppose there are two numbers, 4 and 12, right? What is the SCF of these numbers? The factor that is highest and common. So what is the highest common factor? The factor of these are 1 is a factor, 2 is a factor, 4 is a factor, right? The factors of 12 are 1 is a factor, 2, 3, 4, 6, 12, right? What is the factor that is highest and common? This is 4. Hence your SCF is 4. LCM, least common multiple. What is the multiple? The multiples of 4 are 4, 8, 12, and so on, right? 16. Similarly, 12, 24, 36, and so on. So what is the least common multiple? 12 is the least common multiple. This is the concept behind SCF and LCM. Okay. Now, how to calculate SCF and LCM? Suppose there are two numbers. Let me take any two numbers. Let me take 3 numbers. Chalo. Let me take 20, 30, and what 40. Okay, let me take these 3 numbers. Quickly prime factorize these numbers. Tell me the prime factorization of 20 quickly now. Quick 20, 30, 40. What will be the prime factorization? What is the prime factorization of 20? Good. 2 square into 5, 30. Good. 3 into 2 into 5, 40. Quick, you should get it much easily now. Fine. 2 cube into 5, right? So when I'm taking out SCF, that is the highest common factor, what will I do? If I'm taking out highest common factor, I will take see, 2 is having highest power of 2 here, right? 2 is having highest power of 1 here. 2 is having highest power of 3 here. I will take the least power of these. So the least power of 2 is 1. The least power of 3 is, what is the least power of 3, everyone? In these 3 numbers, what is the least power of 3? 0. Good. That's what I wanted to ask. So the least power of 3 is 0. Hence, that is 3 ka power 0 or 1. What is least power of 5? 1. SCF is 10. Okay. You will always take the least power that is common to the prime factors. Hence, you got SCF as 10. What about LCM? What will be the LCM? In this, you will take the highest power of these numbers, these prime numbers. What's the highest power of 2? 2 cube, which is 8. What is the highest power of 3? 3 to the power 1. What is the highest power of 5? 5 to the power 1. SCF, LCM is 120. Cool. Basics of LCM and SCF and LCM. I think you knew this already, but still, basics of SCF and LCM. Chalo. A very simple question, guys, which you can see on your screen. Just quickly solve it. There are 3 flash board. One is flashing after interval of 3, 5, and 9 seconds. After how much? Exactly. It's a very easy question. After 3 seconds, this will flash. Again, after 6 seconds, 9 seconds, 12 seconds, and so on. 5, 10, 15, and so on. 9, 18, 27, and so on. Hence, what is this question asking? To take out the LCM, which is 45. Good. Very basic question. Okay. Now, there are some properties of SCF and LCM. Let's discuss those properties quickly. The first property is SCF into LCM equal to product of 2 numbers. Okay. Why is this happening? Why is this property coming, or why is this happening? Have a look there. Let's say there are 2 numbers, okay, and their SCF is H, right? And X and Y are co-prime. The first number will be HX, the other number will be HY, where X and Y will be co-prime, right? What will the SCF? SCF I have assumed as H. What will be the LCM of these 2 numbers? What will be the LCM of these 2 numbers, everyone? Quickly tell me what will be the LCM of these 2 numbers. HXY, obviously, right? LCM will be HXY. So can you see here? SCF H into LCM HXY equal to HX into HY. SCF into LCM equal to product of 2 numbers. Another property is greatest number We will also solve question on these properties, don't worry. Greatest number which divides a, b, c and leaves remainder x, y, z is SCF of this. Why is this property coming? Again, due to the remainder theorem. How? Suppose there is a number which is dividing, let's say 15, 21 and 32, any random numbers, okay? And there is a remainder of, let's say 2, there is a remainder of 3, there is a remainder of 4. Taking random numbers as of now. So what will the greatest number which can divide these? See, if a number is leaving a remainder 2 on division, means 15 minus 2, 13 is getting completely divided. If it is leaving a remainder 3, which means 18 is getting completely divided. If it is leaving a remainder 4, this means 28 is getting completely divided. Right, guys? There is a number which is completely dividing all the 3 numbers. Right? So what can be the greatest number? Simply the SCF of. This is the concept behind it. Concept behind this simple formula. But no need to know concept of each and everything, because in a number system there are many things. I will tell you the concept, but it is not necessary that you should know each and every concept. So just remember this as a formula. This is the concept behind this formula. Okay. Right. And this formula is directly used. So you can just remember this. The greatest number will be SCF of a minus x, b minus y, c minus z. Right. We will solve some questions also. If there are 3 numbers a, b, c and they are leaving the same remainder when divided by a number, then what will be that number? That number will be SCF of c minus a, b minus a, c minus b. Again, the same remainder concept. The concept lies in the same remainder concept that I explained you. Ditto same. Okay. Remember these two as general formulas. They are very easy formulas to remember. We'll solve some questions and then it will get more clear. Solve this question. The example that I took, hx and hy, in this x and y were co-prime, because if h is the LCM, then they will co-prime. Then they will be co-prime. Okay. In this case, because I've already taken h as the HCF, right? So x and y will be co-prime. Difference in last two problems. Okay. Here the difference is that the remainders are different. Okay. Remainder is x, y, and z, and here the remainder is same. Like we will solve it by questions. Don't worry. So this is the question, that what is the largest number that divides this and leaves same remainder. So just now we have seen the formula that is leaving the same remainder, right? So the remainder is same. What it will be? SCF of this minus this, this minus this, and this minus this. So this comes out to be what? 156, and then 117, and then 39. So what is the SCF of this? 39. This is your answer. Clear, everyone? Simple question. The concept I've already explained you. What is the concept? But you need not know the concept every time. This is a very simple question. Yes, Priyam. See, greatest number, and here also the greatest number. This question, next question. Here the remainders are different. So this is the difference, Priyam. In first question, the remainders were same. In this question, remainders are different. Good, everyone. Simple question, right? What you have to do? SCF of 48, 120, and 288. What is it? 24. That is your answer. I hope this is clear to everyone. Next question. Now this is an interesting question on SCF LCM. There will be a property that I will use, which I will teach you in integral solutions. Okay. I'll just tell you to remember it as a formula right now. I will teach you this in integral solutions. I will use this here. Meanwhile, try it out. Or let me tell you first, if there are 2 numbers such that xy is equal to, okay, first you try it out. Leave. Forget it, first you try it out. Okay, anyone who can solve this? 3, okay. See, SCF will be 8. That is fine. No, Priyam. No, not needed here. SCF will be 8. That is fine. Right? So assume one number to be 8x, one number to be 8y. What is the LCM? 8xy. This is given as 62832. What is the value of xy? 7854. You know that x and y are co-prime. Now what should be the answer? Till here, I think every one of you would be comfortable, right? This is very simple. Till here this should be easy, right? The value of xy is 7854. So there is a rule which I will teach you when we will deal with integral solutions, that why is this happening. If there are two co-prime numbers and you have to find the number of pairs that they will form, what you have to do is, see, what is 7854? 7854 is nothing but 2 into 3 into 7 into 11 into 17. Okay, this is what this is how we can divide it. So there is a rule. Simply, if there are, see, there are two types of pairs: ordered pairs and unordered pairs. This ordered and unordered, this we will deal in greater depth while we will deal with PNC. This ordered and unordered, this all comes there. What is unordered, what is ordered, everything I will teach you there. Okay, what is ordered and unordered? Basically, ordered pairs are, if suppose if I have given here, there are two numbers x and y, right? So see, I am explaining you. I'm not explaining you the main concept of ordered and unordered because it is not needed as per now. Because we will deal this in PNC. Just for certain clarification, what is ordered, what is unordered? If there it is given two numbers x and y, right? What will be the answer? This will be known as ordered pairs. Why? Because I have already given an order that how to place them in an order. If I am asking x and y, then 2 1 and 1 2 are different. The value of x is 2, y is 1, x is 1, y is 2. But if I am not given these two numbers, so then 2 1 and 1 2 are same, right? Because I haven't specified 2 1 or 1 2 as x and y. So this is the concept of ordered and unordered pairs. So if the number of pair are ordered, this is nothing but 2 to the power number of prime numbers. What is the number of prime numbers? 1 2 3 4 5. That is 2 to the power 5. If I have asked ordered pairs, here I am asking unordered pairs, answer will be 2 to the power 5 minus 1. And minus 1 is nothing but 2 to the power 4. Answer is 16. Right? Why is this happening? See, why is this 2 to the power 5 happening? Because they need to be co-prime first of all, right? Yes, Ishan. They need to be co-prime first of all. So again, by permutation combination. Okay, leave the concept. Remember it as a formula. We will deal it with in greater depth in PNC and integral solutions. I don't want you to confuse here. Leave. Simply, the number of ordered solution will be 2 to the power prime numbers, and unordered will be 2 to the power prime numbers minus 1. As simple as that. Okay. Let's move to the next question. What will be the answer? Algebra mein hai Priyam. In algebra, I will cover integral solutions when we will deal with algebra. What is the answer here of this question? Now, this question again, I'm asking how many pairs AB. So I'm asking what? Ordered pairs. Whenever this is mentioned, I'm asking what? Ordered pairs. SCF of 7 again. So I can assume one number to be 7x 7y. So 7x into 7y is what? 12600. But is 12600 divided by 49? No. Answer is 0. No such pairs exist. Okay. Because x into y is not an integer. Next question. What will be the answer to this question? 16 plus. What is the meaning of 16 plus? Again, this is very simple. SCF is 17. So 17x into 17y. Right. This is the product, but we have been given LCM. So 17xy, the value is 3750. The value of xy is nothing but 210. So just break 210. 210 will be 2 into 3 into 5 into 7. Answer is to the power 4 because I have been asked ordered pairs. I hope this is clear now. Now let's, so what is the time? It is 10. Okay. So let me quickly cover cyclicity as well and then we'll wrap up. Are you following me? See, if there are two numbers, hx, hy, if I will multiply these two numbers, then I will get h square xy, right? But what will the LCM of these two numbers? hxy. Clear, Priyam? Last question. Yeah, this is the last question. Tell me. Let's start this cyclicity of factors. Okay. Ab clear hai? Sabko everything clear, everyone? Yes, in ordered we will do 2 ka power n. So, still there is any doubt, then ask me. Path clear? If yes, then let's start the cyclicity part. See, what is cyclicity of factors. If there is any number, let's assume the number is 2. What is 2 to the power 1? 2. What is 2 square? 4. What is 2 cube? 8. What is 2 to the power 4? 16. I'm only writing the last digit. We will use cyclicity to find the last digit of a to the power n. Okay. And while we are finding the last digit, I'm only concerned with large digit. This is what I'm concerned with. That's it, right? So what is 2 to the power 5? Again 2, right? 32. So I'm taking 2. 6, 64, 4, 8, 6, and so on. So can you observe that the cycle of last digit is 4? That 2 ka power, if I'm talking about the cycle of 2, because 2 is having a cycle of 4 in case of last digits. Is this clear, everyone? That 2 is having a cycle of what? 4. Similarly, what is 3? Check. 3971, 3971. 3 is also having a cycle of 4. So 2 and 3, they both have a cycle of 4. If I am asking about 13, then also I'm only concerned with last digit. If I'm talking about last digit, I'm only concerned with last digit. So what about 3? 3 has cyclicity of 4 and 13 has a cyclicity of 4. Fine. This is known as cyclicity. Now, if I want to compute the last digit, let's say I want to compute the last digit of 143 to the power 35. Let's say, okay. Question is find the last digit of this. I am only concerned with last digit in this case. What is last digit? 3. So the question is asking me what should be the last digit of 4 to the power 35, right? Now guys, quickly, what is the cyclicity of 3? What is the cyclicity of 3? 7. Acha, answer is 7. Okay. Cyclicity of 3 is 4. So after every 4, like 3 to the power 1 is 3, 3 square is 9, 3 cube is 7, 3 to the power 4 is 81. So after every fourth term, this is getting repeated, hence cyclicity is 4. I will just divide 35 by 4. 4 8 is 32. What is the remainder? 3 is the remainder. Why I am dividing by 4? See here. Suppose if I divide this by 4, if I divide 3 by 4, what is the remainder? 3 is the remainder, right? So what is the last digit? 7. This is 3 ka power 5, again 3, 3 ka power 6, again 9, 3 ka power 7, again 7, 3 ka power 8, again 1, right? So if I'm dividing this by 4, what is the remainder? What is the last digit? 7, because remainder is 3 and 3 cube is 7, okay? 14 के कोई रोल नहीं होगा, नहीं 14 का कोई रोल नहीं होगा because I'm only concerned with last digit prium and I'm using cyclicity, that's why, okay? So yeah, so what we have to do is, if the question says find the last digit of 3 ka power 35, divide 35 by 4 because the cyclicity is 4, you will get a remainder of 3. You will get remainder of 3. What does it mean? That the answer is 3 cube. 3 cube means answer is 7. Is this clear, everyone? Why the answer is 7? Any doubts? If remainder would have been 1, answer would have been 3. Remainder is 2, answer would have been 9. Remainder is 3, answer is 7. Remainder is 0, answer is 1. Okay. Now solve this question. This is again an oral question. Quickly solve it. In last digit, I am only concerned with last digits. Just now I have told you. Right. What is last digit of 5 to the power 23? This will be 5 only because why? Cyclicity of 5 is what? Every time it gives you 5. Right. So the cycle is 1. So 5 into 6 is 30. Hence the last digit is 0. I hope this is clear to everyone. Let's go to the next question. Solve. This is 2 to the power 2015. One more thing. 2 square ka cube is this same as 2 cube ka square? Are these two things same? No, right? Just be clear about it. These two things are not same. Now solve. Here, if there is a plus, then you will add it. You will add it. Yes, Hassan, any issues? You raise your hand. What will be the answer of this question? Okay, no issues. Solve it, guys. Everyone solve it. Good, 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 everyone. What is the concept? What have I told you right now? The power to 2 is what? 2 to the power 15. The cyclicity of 2 is what? 4. So divide 2 to the power 2015 by 4. Right? I have to divide this by 4. What is the remainder? 0. Remainder is 0. If remainder would have been 1, answer would have been 2. If remainder would have been 2, answer would have been 4. Remainder is 3, answer would have been 8. Remainder is 4 or 0, answer is 6. You can check by this also. No need to go to this. Just check by this example. This is what? 2 squared cube. Is this same as 4 cube or not? No, right? This is 2 to the power 6. 2 into 3, 6. Right? Okay. What I was saying is, yeah, Said. Said, what is the concept? Whatever be the power of 2, I just have to divide it by the cyclicity, right? And find the remainder. I divided this by cyclicity. The remainder is 0. If remainder is 0, answer is 6. Clear, Said? Any doubt? Yes, yes, exactly, Sashank. Any doubt on this side? Okay, let's take it from the top. Suppose, guys, the question would have been 2 to the power 65, right? Then what you would have done? Then what you would have done? You would have divided 65 by what? 4, right? Everyone, Saeed and others, those who haven't understood, please respond to me. You would have divided this by 4. What would have been the remainder in that case, guys? 1. You could have said, what is the answer? 2 to the power 1, which is 2, right? Here the question is 2 to the power 2 to the power 2015. Whatever be the power of 2, divided it by 4, right? So this is 2 to the power 2015, matlab 2 into 2 into 2, 2015 times. I am dividing it by 4. Remainder has to be 0, obviously. If remainder is 0, this is same as saying remainder is 4, 0 or 4, right? Answer is 2 to the power 4. Last digit is 6. Clear, everyone? What's the answer of this question? Last non-zero digit of 3 to the power this. Okay, I'll try to slow it down a bit, don't worry. Actually, number system is such a huge topic that there are so many things to cover. But okay, I'll just make it a tad slow, don't worry. If in the last question this would have been 2 to the power 3 to the power 2015, then what? If it is clear, okay, then let me proceed with this speed. I'll just slow it down a bit, don't worry, for your comfort. What I will just rewatch the video if there is any doubt, right? Because there shouldn't be any doubt. If in the last question this would have been the question, then what? Again divided by what? Cycle 4. What is 3 mod 4, Sashank? 3 mod 4 is -1. So this is -1 to the power 2015, right, Sashank? What is -1 to the power 2015? Again -1. So saying remainder is -1 or remainder is 3 is the same thing. Okay, but good question. Yeah, coming back to this question, find the last non-zero digit. Okay, who will give me zeros? This 10 will give me zeros. I can break this as into 10 to the power 2, 3, 4, 5, right? So who will give me zeros? This part will give me zeros. Who will give me the last non-zero digit? This will give me the last non-zero digit. Question becomes simple. Divide 2, 3, 4, 5 by 4. What is the divisibility of 4? Last two digits. So divide last two digits by 4. What is the remainder of 1? Hence the answer is 3 to the power 1, which is 3. Clear, everyone? If remainder is 1, then the answer is what? 3 to the power 1. Okay. This question. 3 to the power 2, 3 to is this question is something like this. 3 to the power 3 to the power 3 to the power 3, 2015 times. I think everyone has got it, but still I'm solving it by my method. This is 3 to the power how many times? 2015 times, right? 3 to the power 3 to the power total 2015 times total. So whatever be the power of 3, I have to divide that by 4, right? So this becomes 3 to the power 3 to the power 3 to the power 3, 2014 times divided by 4, right guys? What is this? 3 to the power what? Divide 3 by 4, this is minus 1. So this is what? How many times? 2013 times. It is an odd number of times, right? So minus 1, minus 1, minus 1, minus 1, and so on, right? This will give remainder of 3 because remainder will be minus 1. This will give remainder of 3, and hence the answer is 7. Okay, because 3 cube is 27, answer is 7. Everyone got it? That is good. Okay, so I will end this topic here. The cyclicity part, I'll end it here. And following this, what we will discuss is remainder theorem concept. Not remainder theorem exactly, but remainders ones, right? Followed by remainder theorem, and then we will take up some very interesting question. Okay. Okay, what is the doubt, Mukul, in this question? One question I want to give you as homework. What is the doubt? See, this is 3 to the power 3 to the power 3 to the power 3. How many times? 2015 times, right, everyone? What is my concept? I have to divide this, whatever be the power, by 4. Is this my concept, everyone? This is my concept, right? So 3 to the power 3 to the power 3 to the power 3, 2014 times is divided by 4. I hope this is also clear, right? So what is 3 divided by 4? Minus 1. To the power what? Minus 1 to the power minus 1, and so on, right? So hence this will be at minus 1 only, right? If it is minus 1, then it will be 3, because I can say that remainder is minus 1 or the remainder is 3. Both are same. If remainder is 3, answer is 3 cube, that is 7. Because I'm getting remainder as odd number of time multiples of minus 1, right? Hence minus 1 is the remainder or 3 is the remainder. Today only I will upload part as usual. Okay. Okay, this is a question from my another class. Fine. Yeah, I want to give you one more question which I haven't by mistake. I have included the question from the CISI class. So let's take this question. Solve this question. 3 to the power 4 to the power 5 till 10, right? Find the last digit of this. Take it as your assignment and solve it out. 3 to the power 4 to the power 5 till 10. What will be the last digit of this? Okay. Priyam, just look at the explanation that Sashank has given. It is same. Hence, it will be that. That will be the answer. Okay, solve it. Solve this question, and then we will see. Right. It's a simple question, right? Anything to the power of 3 should be divided by its cyclicity. What is the cyclicity? Cyclicity is 4. So anything to the power of 3 should be divided by 4. This is 4 to the power something, and this is completely divisible, right? If this is completely divisible, then answer the remainder is 0. It is same as saying remainder as 4. Answer is 1. Clear? Okay, don't make silly mistakes. I hope this is clear. So we have completed cyclicity today in this class, and in the next upcoming classes we will see remainder concept followed by remainder theorems. The next class is going to be an interesting one. Stay tuned. And then we will also cover base system in the last class. Chalo, have a good day. Thank you guys. Good night. I hope the session was good.